Thank you, Bal. And the last part of our first half of the meetup will be a 15-minute talk by Olga Megorskaya, CEO of Toloka AI. Toloca or Toloca, what is the right? Toloca. Toloca is a kind of new guy in the block here in Israel ecosystem, but actually it's a well-acknowledged platform for data labeling and crowdsourcing. And Olga will talk about this during her talk.
Thank you, Kostya. So this is the last talk for all the brave people who kept here. So let me start. How does it? What did I do? Okay. So a couple of words about myself. During my career, I've managed to at first build up the in-house data labeling service for the huge enterprise industrial search of Yandex. I actually learned how to build this in a bit similar way to what Inbal had been describing so far about all the positive effects of in-house labelers and unfortunately all the limitations of the in-house labeling services. Then we have created and developed our infrastructure to cover not only the tasks of the search, but to provide the infrastructural service for different technologies which are using machine learning in Teloca, which is a general purpose crowdsourcing platform which is used by many different companies and many different AI teams all over the world to collect human labels on a large industrial scale. And that's what is it happening?
It's the bottom one.
Really?
Yes.
3.
Wow.
It needs to go through validation.
Wow, that's unbelievable. Yes. Okay. So what Teloca is, it's actually the basis of that is quite simple. It's an open platform where anyone can register as a requester, and mostly these are AI teams of different companies, of technological companies who are driving AI products. And anyone can register as a performer. We call our performers Telocers, who choose the tasks which are interesting to them and perform them. And in between, there is a Toloca as a smart platform which provides all the tools for quality management and all of the other infrastructure needed to process these ongoing pipelines of data labeling. In a way, the major asset of Toloca is our global crowd. I would say that right now Toloca is, well, at least one of the biggest, or probably the biggest crowdsourcing platform in the world. We're covering more than 100 countries with all the major and most popular languages in the world. And we have more than 10 million people registered in the platform and more than 200,000 people earning money on the platform every month. On the other hand, there are the whole bunch of technological solutions which allow requesters to automatically manage the minor efforts of those millions of people in order to set up the pipelines for data labeling. And actually this combination of the power of the crowd from the one hand and the technological solutions on the other hand is the core value that Toloca brings to the requesters, because this is the approach that allows us to kind of treat the data labeling as not a people management, but rather a technological and engineering task. Because this is what allows the requesters to actually establish the data labeling on a really, really large scale without losing in quality. Couple of words about our history. Actually, Toloca has been founded in the end of the year 2014, quite long ago already. And since that time, we've been growing constantly year over year, both in terms of people who are participating in performing the tasks and a number of the teams and the projects which are running on the platform. And a couple of words about that part, because initially, as I have mentioned, we have started in building the in-house data labeling solution, the in-house service for data labeling, We started with like 5 people at the beginning, then it was 15 people, then it was 50, then it was 100. Then when the numbers grew to 2,000 people, at one moment we realized that, oh my God, we're doing nothing but the people management. We are solving nothing but the questions of how to hire these people, how to fire them, how to manage, how to control them, where to find the place, just as Inbal mentioned, where to find the room or the method how to connect them together to discuss some disagreement cases and etc. etc. And at some moment of time, you just realize, like, oh my God, I spent 6 years at the university studying maths, and now I'm just solving the purely HR problems. And this is something which is not very like interesting. And probably this is where I would say the attitude towards the data labeling as being something unsexy and not interesting came from, because really, unfortunately, the additional costs that you need to provide in order to manage the whole process of data labeling were really, really huge. And then we understood that we need to like go to another approach, and to scale further, we have opened Teloca as an open platform, and that allowed us to grow substantially. After that, we started observing the real boost in number of projects, a number of teams who are participating, a number of people who are performing the tasks. And I believe that there were 2 main reasons for this quantum leap. One is quite trivial. Of course, it is like purely administrative thing, like removal of administrative barriers, and the access to much a bigger crowd allowed many teams to start using data labeling on a larger scale. But what I think is more important is the change in engineering culture when we gave the engineers the ability to actually set up their own data labeling processes and think of the questions which Inbal also mentioned, which are the core and very important questions of how do you control the process of data labeling. And that allowed actually the teams to come up with lots of very creative and interesting solutions for their data labeling processes. So I would say there are 3 major benefits of using large-scale data annotation. First of all, of course, this is like if you spread the same amount of data between the larger number of people, you can collect the same amount of data in a shorter time. Secondly, you reduce significantly the administrative costs of managing the people. And thirdly, which is, I think, the most valuable part, is that you reduce significantly the life cycle of experimenting. You can very fastly launch something, get the feedback, understand, then try again and again and again. I would like to cover several of the use cases to illustrate how different teams and different companies are approaching their tasks related to data labeling on our platform. To be honest, this is the coolest part of being the infrastructural platform, is that it allows you to observe the trends of the industry and see very different use cases and how different teams are solving their problems. And I'd like to share several use cases just to give you the insights of different approaches that can take place. So first one is the self-driving cars. Everybody likes the use cases about the self-driving because they provide very nice pictures. Probably most of you have seen that. Yes, the self-driving presumes lots of data collected during the rides, and it needs lots of data to be annotated constantly to support the changing environment and etc., both in 2D labeling and 3D labeling. And in our context, it is interesting to see how actually the data labeling pipeline looks under the hood. Because if you need thousands of images labeled every day, you need to have a scalable pipeline which is resistant to mistakes of single performers. And this is one of the examples of how the pipeline might look like. So at the input, we have the big pool of annotators. We call them Telocas. Then they are given access to the training pool. And actually, training of annotators is in a way similar to the machine learning approach itself. At first, you provide people with a bunch of, like a training set, yes, a bunch of cases where you illustrate, okay, here the correct answer should be like this, here like this is the explanation why it should have been labeled in a certain way. Then after people pass through, I don't know, 10 or 100 use cases, they kind of train their own neural network, understand the logic of the task, and then they are given the access to the examination pool when the requester actually validates how the annotator understood the logic. And those who have passed the exam with quite a high level of accuracy are given access to the production pools. And then there is a loop of those who didn't pass. They are given second chance in several days, and etc., etc. Then, so people are given access to the production pools, and then there is a core part of actually all the crowdsourcing projects is the decomposition of the task. If you provide the picture with people, cars, trees, pedestrians, bicycles on the street, etc., and say, okay, label everything, it is really a hard task and very easy to make mistakes there. So what is done? The task is decomposed into several pools. One is specifically related to pedestrians. Another is specifically related to cars. Another is specifically related to traffic lights and something else. And then there is a multi-step task. At first, you provide the classification. Please select only the photos where there are pedestrians. And several people in an overlap of, for example, 3 vote. This is a fairly simple task. Okay, if 3 people said, okay, here is the pedestrian on this image, we can say, okay, then this task is given to another round where people are asked, okay, here is the pedestrian, just highlight it using a polygon. Then there would be the third step where another people are looking at these highlighted pedestrians and vote, okay, whether it has been done correctly or not. Pretty much similar to what Lotam showed at the beginning, where you were asked whether the dots over the face are given correctly or not. And after we have such a pipeline, actually the beauty of that, it is that on the one hand, it is powered by human. On every steps of that, you are collecting real human labels. But on the other hand, it is designed in a purely automatical way. And once it is set up, like every step is covered with the metrics you can consider, like with the accuracy, etc. And once it is set up, the cool thing is that it's only a function of how much money you throw in the input of that, how much output you get. And this is very important for scaling. If suddenly you need to label 10 times more than you needed yesterday, with the in-house service, you unfortunately cannot do this. But when you have already this pipeline set up, it's actually not a question. Another use case is not related to computer vision. Since Teloca is a general purpose platform, we have different domains of machine learning applications. The interesting use case, we recently had been participating together with the research of Microsoft and Meta in the World Machine Translation Conference, where Telocas were evaluating the quality of different machine translation engines. So they have collected 10 language pairs. The task was something like that. So there is the text and the options of translation, and people needed to vote whether the translation is correct or not, and how the pipeline looked like. So these are the several language pairs that were chosen. Since Teloca has a global crowd of different people from different countries, we have found lots of people speaking different pairs of languages. How do we verify that they really speak that? There was a language test which is untrivial because it is there are pictures, so you cannot just Google it, and there is the time limitation. Like if you know the language, you would answer this question pretty fast, like within a couple of seconds. If you don't know the language and you would need to go to the translator and etc., you would fail the timing. So that's how the basic verification for knowing the languages was applied. And then there is quite a similar pipeline. At first, all the people pass through the language test for the specific language. Then those who have passed it go to training and examination. And then there is the task of verification of the translation is given to several people. There is the dynamic overlap. So the same question is asked as many people as needed until we reach the accuracy of, say, 99%. So in some cases, in easier cases, it is enough to ask, I don't know, 3 people. In more difficult cases, you would ask more and stop until when you get the needed level of accuracy. Then you aggregate the votes and get the final quality, which was get the final labels, which were used in measuring the quality of machine translation systems. And now actually we are continuing this project together with Meta and now researching also the translations for rare African languages. It's a very interesting project. It's running now. Hopefully in a couple of months I would be able to tell you the results of that. Another approach that is quite oftenly used on Teloca is human in the loop. It's the combination between automated verdicts from the models and people votes. One of the very interesting examples is so the company is doing business in digitalizing handwritten documents, checks, and etc., etc. Of course, they have very good models which automatically execute, I don't know, 80% of all the cases. But then there are 20% of edge cases, really difficult ones. What do? They send them to Teloca. So they decompose these documents into small pieces of information. Like the task is very simple. Here is the set of digits. Just rewrite them in a digital form, right? It's a very trivial task for the human. And because there are so many people at every moment of time operating in the platform, they are able to provide like the real-time human annotation within 6 to 8 minutes. So the whole, whichever document you take, within 6 minutes, it will be fully transcribed. And the pipeline looks also quite similar. So they get, for example, if it's invoice, it is decomposed into pieces. Every piece is sent for the human. Then it is verified, like another human would look at the pair of digits and say whether it was transcribed correctly or not. If yes, the task is accepted. If no, the task is rejected, and the loop is repeated until you get the correct transcription, and then you get the final result. And all this runs within like 6 minutes. And the last part, also Lotta mentioned that at the beginning, in many cases of applicable machine learning, actually you need, and that is interesting, speaking about the trends, we see this trend really growing because the further AI applications go to offline, the more applications there arise, the more the demand on data collection tasks. Because you cannot rely on, unfortunately, yet you cannot rely only on synthetic data. You would need, well, there are lots of really, really strange tasks that we see on the platform, like collecting the videos of how people wash hands or something else, because there are so many really untrivial applications of AI that we could have never imagined that they actually exist. One of such use cases is one of the requesters on Teloca have collected the videos of people's feet. Why did they need it? Because they were creating the app for like something like 3D trying on the shoes. So they needed very large data set of different feet of different people. Unfortunately, there is no standardized solution for feet like there is for yet. Yes, it's not such a popular use case yet. So they had to collect real feet of real people. They actually collected videos, then they decomposed those videos into just images, and thus within the real short time, within 5 days, they have collected a really, really huge data set of people's feet. Yeah, and the pipeline was quite trivial. So at first, you ask person to record the video of their feet. Then there is the post verification when people are asked to watch this video and say, okay, this is correct or not. If it's correct, then it's accepted. If not, it's rejected and repeated until you get the needed amount of data. The last thing that I wanted to mention is that by its nature, Teloca is an open infrastructural platform, and we see ourselves as our mission actually to give the ability for all the engineers to smoothly integrate data labeling on the large scale into your machine learning production processes. And if among you there are people who are dealing with ML ops and covering some parts of machine learning production, we are very open for collaboration because we have all the tools for smoothless integration via our API and etc. Probably the last thing is that this is the first of the series of events we are planning to attend and organize here in Israel. I'm really excited about the vibrant community of AI here in Israel. We are going to have more of them, and if some of you are willing to give a talk on different topics, like one of the nearest ones, one of my favorite things that I think should be really exciting is about crazy data sets. If you have been dealing with some of those, please contact us. I think we can collect a really, really funny story for that. So please, we would be happy to see you on our talks. And if you are willing to try Teloca by yourself, actually, please take a photo. This is a promo code for some budget which you can spend on Teloca to try the product by yourself. Thank you so much. I guess that was it.